Welcome to my series of solving Project Euler problems in Python, both in quick ways and more efficient ways. I am now at problem 10, which is a bit similar to problem 7, where they asked us about the 10,001st prime. I do recommend watching that one for a bit of background on prime and prime sieves. In this problem, they ask us about the sum of all primes below 2 million. With a similar prime sieve as the one in problem 7, this is not a complicated problem. So a quick recap. A prime sieve will find all primes in a given number range by starting low and filtering out multiples of known primes. This is a fairly efficient way to find primes, though it uses a bit of memory. Since we know that we want all primes below 2 million, I can just look at those numbers. This is simpler than in problem 7, where I didn't know how many numbers I would have to look at. I will start with the example as usual, as a way to verify that the program is not completely broken. The sieve will return a list of true/false for all given numbers. Looping through the range of numbers from the start, we know that anything that hasn't yet been filtered out is a prime, and when we find a prime, we filter out the multiples of that prime. Now we have our list, and we can sum all the numbers where the list says true, i.e. all the numbers that are prime. You could write all this as a one-liner, but I prefer code that is easy to read, even if it is less compact. And as always, I will print how long this took so that we can see how efficient the solution is. So starting with the example in the problem. Python, problem10.py. The program says the answer is 17, just as the problem text did. Now the real problem, all numbers below 2 million. Oh, below, not including 2 million. So I looked at one number too many. It did not really matter, as 2 million is very much not a prime, but right should be right. So let's see how slow this is for the full problem. The answer for 2 million seems to be about 143 billions, and it took a full 1.3 seconds to calculate, an infinity for a computer. I do not think I can make it much faster without changing programming language, but I guess we can sum the numbers as we go. So I'll change the program to do so, deleting the second loop, and the prime sieve function can now do the sum and return the sum of the primes. And is this faster? Looks like it was 10% faster. Not much, but I think that is as good as it gets. I hope you enjoyed this quick tour through problem 10, and welcome back next time for more Project Euler problems. And please like and subscribe.